So who knows what stream processing is? I think we also learned a lot from this morning's talk by Jay Krebs. Who here has actually used a stream processor before? OK, maybe half of the room. I just wanted to make sure if I should focus more on the technical detail of the implementation versus the features and benefits. But in general, I'm going to talk about stream processing, how we see stream processing in the market, and what features of Concorde can really help you to do stream processing and real-time application, and how we are planning to develop Concorde further down the road. So what is stream processing? We basically see stream processing as processing data in motion. In the past, or traditionally, most of the people have been processing data at rest based on the database, either running a job or querying the database. But when there's a lot of data, and you want to get data results faster, you might want to process the data even before it hits the database. So most of the stream processors today generally sits between message queues like Kafka and databases like Cassandra or HDFS. A lot of people use stream processing to run the faster ETL jobs, whether you want to enrich the data, if you see a user ID and match it up with the actual username. If you want to do a fast aggregation, let's say you want to gain the real-time click-through rate per publisher if you're an ad network. Or if you want to do filtering and deduplication of the data so you can get unique URLs that is trending currently. So if you look at this, it's generally like a faster MapReduce job. But as you run more stream processing, you'll see that you'll end up running a lot of your application and core business logic on top of these streaming data. My team and I come from working at a large private mobile exchange network where we were processing about 10 to 15 billion transactions a day. And we were running fraud detection on impressions and clicks. We were also going through a very fast budget update of the advertisers so that they don't overrun on their campaigns. But also, every time we see someone actually downloading an app or buying something on the website, we want to use those events to trigger our machine learning model so we can bid better and run our auctions better. So these eventually really become like an application and like a little like microservices that are running on top of data streams. And in order for you to run these services, you do need the support for managing these applications, like how to run clusters, what happens if the job fails, how do we monitor so that all the jobs are running at the same performance that we want it to be. So those are a lot of the issues that we personally had with Apache Storm and what we wanted to solve. So in high level, Concorde is a distributed stream processing framework. We designed the Concorde for high performance real-time applications that require flexibility and control. Currently, the core of Concorde is written in C++ as a Mesos framework. We have a very tight integration with Apache Mesos, which I will go into in a minute. So in Concorde, we, as other stream processing frameworks, sit between data sources and data sinks. We see our world as the logical layer where our users or developers program their operators or the business logic or application logic, what you want to do with the data, or if you want to call an API afterwards or write to a database, that's all totally fine. And we see another world of Concorde in the physical layer part, where which operator to run on which machine, what needs to happen if one operator goes down, and how to replicate data inside. And those are the part. The physical layer part is the part that Concorde automates for you and takes care of it for you so that you can really focus on this logical layer of creating operators and managing those logic. So to go into a little bit more detail, as I said, we see the world of streaming applications as operators. In a way, you can see Concorde as like a global pub/sub mechanism. Basically, each operator can publish to any data stream by declaring a name. or subscribe to any other operator by specifying the name of the stream. So these stream names will be just a globally unique name inside Concorde. And if you want to just, if you say, I have another operator that I want to consume words, then I can just add another operator. So declaring operator is just as simple as defining a metadata where you define the name of the operator, names of the input streams that you're subscribed to in iStream, and names of the output streams that you're publishing to. This operator, you can write it in multiple languages. Right now, we natively support Python, Ruby, Go, Java, Scala, and C++. Each operator has more or less like a primitive API functions. Process record gets called every time message arrives to the operator. You call produce record every time you want to emit data. And you can use process timer to run a timer callback function. We also support each operator with its own local caching mechanism backed by RocksDB. So you have your own little key value store that you can run through the latest count or aggregation that you wanted to do. And we currently support 3 different routing mechanisms for messages: shuffle, round robin, and group by. So with group by, we use consistent hashing so that each operator gets the dedicated key value key that it's assigned to. So just like you can write each operator in different languages, different operators written in different languages can also talk to each other inside Concorde. So if you have a team that is writing their ETL jobs in Scala and wants to push that to your data science team so that they can run their own model in Python, you can do that in Concorde very easily. This is something that's very specific that we personally ran into in our previous company where we had multiple different teams having their own execution environment that they wanted to use. So let's say you've created an operator and now you deploy it. What happens is that we tar your operator up, put it onto the cluster. Our scheduler, along with Mesos master, will schedule this as a Mesos task to run it in one of the Mesos agents. Because we have a very tight integration with Mesos, we get the benefit of running a dynamic resource scheduling, which means as you want to scale, you just add more Mesos agent, and those resources will be available for any of the operators to consume, or if you want to deploy more operators. What also happens is each operator is running in its own execution environment, so it's isolated. If any of the operators is malfunctioning, you don't have to worry about crashing your whole cluster or any cascading failure because it's completely isolated with CPU, memory, and disk. It's also supervised from the Mesos, so if any of the job fails or node fails, we can retry the job to run again. And this can be configurable in terms of how many times you want to rerun the job in the case of failure. And last but not least, we have a high availability. The brain of Concorde, which is the Concorde scheduler, along with Mesos Master and Zookeeper, are all replicated. So if any of those nodes goes down, your services will still running. So now, for the operator, when it gets to Mesos agent, how it runs is its own execution environment. So we use a Mesos container right now. You can use Docker container here as well. And each executor has its own tracing engine, lock-free message queue, router, and the key value store that you can use for local cache. Because we come with the key value cache and the message queue inside, and the tracing engine. In order for you to scale, all you really have to do is add more nodes. You don't have to grow multiple stacks together. And because of the containerized environment, we support multi-tenancy. You can run multiple applications at the same time. And last but not least, you can really truly manage a dynamic topology, which means if you want to add a new operator, or if you want to scale out an operator, you don't have to worry about your downstream operators or having to restart them. And because in an environment in Apache Storm or Spark, you basically have to hard restart the whole topology, your whole job, whereas in Concorde, you don't have to do that. So what I mean by this is your runtime environment is very flexible. So this is a simplified version of what an ad network would do, or a publisher would do. So there's a bunch of raw events coming in, impressions and clicks. We'll do some count, and then there's a click-through rate that we're going to put it on Cassandra, let's say. If I want to deploy a model that calculates trending URLs, all I do is I deploy another operator that listens to impression count and the URL that comes with the event, and that's it. You don't have to restart or touch anything else here. And this can be also applied to any of the data sources or sinks. And you don't have to worry about anything that's currently running. Same with scaling up or down. So what's great about this is that you can iterate very quickly and change things without worrying about bringing down the whole cluster or affecting other jobs that are running that's deployed by other teams, which we think is really helpful for companies that want to move fast and change things as on the go. Another part that Concorde supports is distributed tracing. This is baked inside the framework. So we have a probabilistic tracing system built in. Basically, we paint the packet at the source about like every 1,000 messages, and we follow through the entire computational topology and measure its latency per operator. We recently integrated this with Twitter Zipkin, so you can see, like in a more visualized fashion, which operators are running in parallel, which ones are running sequentially, and where there could be a potential bottleneck for you to actually scale. Moreover, each operator also comes with its own metrics. So latency, throughput, and also hardware utilization. We currently show it to you as like a log from Mesos. It's just available on the Mesos UI. This really gives you the visibility inside the framework, so you can actually debug things very, very easily. Another part that we feel really proud of is that Concorde performs really well at scale. We've ran 2 different types of benchmarks so far against Storm and Spark streaming. I won't go into too much details, but basically what we've found is that Concorde runs at a very consistent performance. Doesn't matter what types of job it is. One thing that we found with Storm was that JVM ends up taking a lot of resources, or at least 10 to 20%, which gets a little bit unmanageable at scale. One thing that we found about Spark streaming is that if you have a job that requires a lot of internal state management, for instance, if you were to do a very tight windowing, like every second for like a 10-second window, your throughput goes down drastically. Whereas for Concorde, we've seen a very consistent performance against different types of jobs that we run. We basically tested against 7 different types of jobs, deduplication, counting, pattern matching, that also happens on time windows and count window basis. So I'm happy to tell you more about this if you're interested in the benchmark later. So as I was talking about performance, one thing that we really wanted to convey with Concorde, and the reason why we decided to write Concorde in C++ is for predictability. As you scale up, basically any JVM systems, you do have to configure JVM so that it works right. You could configure it to run it at the current scale with current types of jobs. But in order for your framework to handle many different types of jobs, it really becomes a challenge. Basically, that's what we found. There are definitely approaches of the frameworks that are trying to solve this issue on the JVM front. But for us, we wanted to have a very basic, very simple, predictable system. And that's what we're designing for. And with Mesos' help, the whole cluster of Concorde is basically abstracted as number of CPUs, memory, and disk. Hence, in order for you to optimize your job, to run your application, you really have the fine-grained or full control of your runtime of the application. And with this, again, what we are really shooting for is for teams to develop their application, compile it, test it, run it, deploy it, see how it goes, and then do that whole iteration again really quickly without any downtime. So one question that we get always asked is the message processing guarantee. Currently, Concorde is best effort processing. What this means is that if your operator crashes or if your node crashes, your local cache will go away. So we generally recommend our users either to have a check mechanism if you really care about it, or most of the applications that we were looking at was something that requires or has a very high temporal value of the data. Because after a second, what happened last second may not really matter. So we basically value being faster more than complete or perfect. However, we are currently working on our integration with Kafka, where Kafka becomes our message bus. So instead of using our own lock-free message queue, we'll always ask Kafka, and it will also tell us if any of the jobs fail, so where we should pick up the messages from. And eventually, we should be able to support exactly once processing, where we currently have a design of a transactional data store that we want to use inside Concorde. So with this, some of the things that we are currently planning right now, the at least once guarantee with Apache Kafka is definitely one. We're currently also looking into DCOS integration. DCOS has a great UI. We've also worked with Marathon before, which we really like. So we're really excited to do that. We currently have pre-built connectors for Kafka, Kinesis, and Cassandra. But we do get asked questions, and we, based on demand, we want to build more sources and sync connectors. And last but not least, having more support for higher level DSL is currently in plans. So in summary, for Concorde, Concorde is a stream processing application framework that you can use multiple languages for. We basically see the world of stream processing with the models of operators talking to each other, which we believe that it will allow multiple teams to operate on same streams of data and actually iterate very fast. With the dynamic topology, you don't really have to worry about bringing down other jobs or cluster when you're updating or scaling. And which means like really the decoupled way of approaching the development versus DevOps work, because you should really worry about the hard application logic without having to worry about how they actually run at scale. So we really want to separate that divide. And last but not least, Concorde is pretty performant at scale. We basically run any events at milliseconds of latency. Our framework inside latency per event for P99 is about 10 milliseconds. And we want to have this performant applications to run at a very high predictable manner for real-time applications. So if you ask me where I should, or why, or how I should use Concorde, currently we recommend Concorde for use cases of real-time applications, again with high temporal value that you want to process as much data as you can, but not having to worry about the full completeness or correctness of the result. So some of the use cases that we've talked to companies in the past include fraud detection in real time, as well as doing tick data processing in financial markets, as well as for a lot of real-time bidding applications. So if this is interesting, you should check out Concord.io. And I'm happy to talk if you guys are looking for any specific stream processors for your needs, since we've also looked into many other alternatives in the market. So, yep, I'm happy to take questions.
What's your model for interfacing with all the other existing systems? Is it that you're going to build operators that talk to HBase, Kafka, RabbitMQ, whatever it is?
Yeah,
so you're kind of in the space of being the message broker, or the thing passing data from one place to another.
Yeah. So the question is, what's our approach for other systems that interfaces stream processor or interfaces Concorde? Right now, all of our client APIs and these operators are open source under Apache license. We plan to build more ourselves, but we also want to have more people to try it out and build different operators on top of it. So that's our approach. Go ahead.
I know this is a future plan. Do you have a sense of how much overhead you're talking about for the at least once delivery?
So the question is the overhead that we predict by incorporating at least once. Kafka is a fairly performant system, so we wouldn't say it's going to be that much of a hit. We've seen some preliminary result, but we want to make sure that it runs at full scale before we talk more about it.
Cool. Thank you.
Yep, go ahead.
Can you say more about your language bindings, and are you happy with how the amount of work that it was to do that? Or whatever?
So the question is about language binding, and you want to.
Bindings, yeah.
Mm-hmm.
Yeah. So, are you happy with the way that went and the amount of work it took to do that, and maintainability, or would you do something differently?
Okay. The question is if we are happy with the work that we put in for the language bindings. It was definitely a lot of work. For sure. So our transport layer, how we communicate between the protocols is Apache Drift. So any Drift language can be supported on top of Concord. However, every time we change any parts of Concord, we do have to update all the APIs. So it is a lot of work. We have had this conversation about whether we should really do more language support. But we think that is a part that that as we build out, have more adoption and have more people using Concorde, more people can contribute and build it as a community project. So, go ahead.
Hi there. Can you say a few words on how Concorde uses Mesos to scale a job over time?
So the question is how we use Mesos to scale job over time. And when you say job over time, what do you mean
so for
by that?
example, when you deploy a framework, Concorde has a Mesos framework, does it acquire tasks and hold on to them forever, or does it have any dynamicism within that?
Right now, we don't do anything around auto-scaling. Basically, we encourage you to actually see the Zipkin interface time to time to see if any of them are hitting any bottlenecks on their latency and throughput. But generally, how you scale any Concorde operator is by just deploying the same operator more. And then we'll figure out how to basically reroute all the messages amongst all the operators that are deployed.
Thanks.
Does that answer your question? Okay. Any other questions? Yes?
So is it relatively easy to have one of these, you call them processors?
Operator?
Operators, which are, I guess it's an actor, sort of like an actor in akka? Or?
You could see it that way, yes.
So it's easy to just bring in your entire sort of machine learning stack, like if you do in Python or Java, you can bring in all various libraries there?
Right, so the question is how easy it is to use the API to run your existing models. Basically, it's basically your code. You would just use the input of the messages, how you process it, and how you want to emit the messages using the Concorde API. In terms of what you want to do with the model or libraries that you want to use, that's all up to you.
Okay.
So we do not force any data-related APIs at this moment.
Okay, but I'd be responsible for ensuring that whatever node has all the various tools. Like, you're not concerned with that aspect, right?
Yeah, which doesn't matter which libraries you're using or what you want to run inside is completely up to you. Yes?
So Concorde itself is proprietary, like the actual framework itself, but the operators, the interface, external systems are under Apache.
That's correct. Yeah. So the question is if we are proprietary software at this moment. All of our client APIs and connectors are open source. Our core that's written in C++ is currently closed source. We do have plans to open source as we figure out our business. But yeah. Go ahead.
Did you, I wasn't clear, did you say that operators in Concord are stateful? They're able to use state?
Yes. Yeah.
So,
Yeah. Go ahead.
what happens in the case of failures with regard to that state? Or as you said, you can just add more operators? What happens with regard to state?
Right. So the question is what happens to the state when the operator fails or as you scale out the operators? Basically, the current state will be lost. That's why we are a best effort at most once processing. But as we integrate with Kafka, you'll be able to take the state of it from the Kafka and process it from wherever you left off with the messages.
You're going to use Kafka as a state.
You will manage state and where we left off on the messages with Kafka as well.
Actually, it's saying the message will never lost.
What's that?
That would be delivered at least once, so never lost. So you can deal.
So, I mean, our Kafka consumer currently works as an at least once approach. So if you use that to read off from Kafka, anything that goes down, it will read off from the wherever that it left off from the partition. All right. Well, if you guys have any questions, I'll be over here. So let me know. Thank you for coming.